Get to question 11 on the Physics Bootcamp addendum. It says a measuring stick on a rapidly rotating disc will not appear to shrink if it is oriented along the what? A, circumference of the disc, B, radius of the disc, C, either of these, and D, neither of these. Right? So let's visualize this. Imagine there's a disc here that is rotating. Right? So if we put the measuring stick from the center radially outward, will it appear to shrink? Well, think about all the points of the ruler, right? The ruler is moving this way. This point is moving this way faster, 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 right? So will this length be contracted? No, right? Its width will be contracted a little bit. So just like we were saying in the previous questions, the dimension parallel to the dimension of travel is the one that is contracted, right? So the width will be contracted, so it will appear like this, okay? It will appear from a person, stationary reference frame, it will appear as if the width of the ruler is contracted, so it will appear like this. As a matter of fact, which one will be contracted more? This one is not traveling as fast, right? This one is traveling a little bit faster, a little bit faster, a little bit faster, a little bit faster. So the one that's exactly at the center is not moving at all. It's just spinning, right? So the one at the center, the width at the center will not change. And as you go, they're gonna get closer to each other. Okay? So it will look like this. The length will not be affected at all because the length is perpendicular. You see here? The length is perpendicular to the direction of travel. What if you were to put the stick along the circumference, right? And as it was going this way, what would happen? Well, in that case, the velocity is this way, right? V tangential. It's actually parallel to the length of the ruler, right? So what is it going to appear? So in that case, it will contract. The width won't change. In this case, the width is perpendicular, right, to the direction of travel. So it's going to appear this way. Same width, just shorter. Okay? So it will go this way on the disc. If you put it from the center radially outward to the edge, the initial width won't change. And then as you go along, the width is going to decrease and decrease. But the length will not change. Okay? So in this case, it says a measuring stick on a rapidly rotating disc will not appear to shrink. The shrink is talking about the length. Okay? Length. So in which case is the length not affected? So it will not appear to shrink if it is oriented along the what? Okay? Well, if it is oriented along the radius of the disc, B. So the choice is B. Another interesting aspect of this is we can ask this: what if there are two clocks? Okay, what if there are two clocks? Which one will run slower? Which one will run faster? Well, which one is accelerating more? As a matter of fact, we could even imagine a bunch of clocks, right? Which one is accelerating more? Well, this one is farther out. It has the bigger acceleration, right? From mechanics, we know that the centripetal acceleration along a rotating disk is equal to r squared times omega. Omega is the rate of rotation, right? Omega, it's measured in radians per second. So when you have a solid rotating object, all points of the object, no matter how far they are from the center, are rotating with the same omega. They have the same rate of rotation, right? So if they have the same rate of rotation, which one has the greater acceleration? The farther away you are, the more the acceleration, right? So therefore, clocks over here will run slower than clocks at the center. So this one is the slowest. This one is the fastest. As a matter of fact, this one is not affected at all, right? It's just basically stationary. So this was kind of equivalent to say that the ruler will look like this. It will look wide here, and then as you go along, it will get thinner and thinner and thinner, right? So if we explain this in terms of gravity, which one has the gravitational field, stronger gravitational field? The one at the end, right? So if you were actually a person, imagine that this is in outer space, and there is a spaceship that's rotating, right? There's a spaceship that's rotating, and people are walking along, and it's rotating like this. So it could be this huge spacecraft rotating in space, right? Who would experience the most gravity, right? So you could actually mimic the effects of gravity. The one at the farthest end will have the biggest gravity. The one at the center will have no acceleration, no gravity. They will not feel the effects of gravity, right? So to them, it's like as if there is no gravity. To the one at the end, they have the most gravity. So also, who will age more, right? The person at the center ages more, ages quicker, and experiences less gravity. The person at the end ages less. Of course, the effect is very, very little, so you could only tell by atomic clocks that there is a difference, okay? Now you can see how to answer this and what the meaning of it is. Thank you very much.